Look up at the night sky. What do you see? Twinkling stars, a distant planet, maybe the pale glow of the Milky Way. Now imagine that every point of light you see represents billions of stars, each potentially orbited by planets just like ours. It's a mind-boggling thought, isn't it? That's the universe we live in. Vast, mysterious, and full of possibilities. For centuries, humans have gazed up at the cosmos and asked the big questions. Are we alone? Is there life out there? These questions have fueled our imaginations and driven us to explore the unknown. Today, with powerful telescopes and sophisticated instruments, we're closer than ever to finding answers. Our journey begins right here on Earth, a tiny planet, orbiting an average star. But from this humble vantage point, we're embarking on an incredible adventure to unravel the secrets of the universe. We're searching for signs of life beyond our planet, seeking to understand the fundamental laws of nature, and pushing the boundaries of human knowledge. So, buckle up, fellow explorers. We're about to embark on a cosmic journey filled with wonder, discovery, and maybe even a few surprises along the way. Before we can even begin to fathom the vastness of the universe, we need a cosmic yardstick. The distances involved are so immense that using familiar units like miles or kilometers becomes impractical. Instead, astronomers use a unit called a light year, which is the distance light travels in 1 year. Light, as you probably know, is incredibly fast, zipping along at a speed of approximately 186,000 miles per second. In 1 year, light covers a distance of about 5.88 trillion miles. That's a lot of ground to cover. To put it in perspective, the nearest star to our sun, Proxima Centauri, is about 4.24 light years away. Think about that for a moment. The light we see from Proxima Centauri tonight actually left the star over 4 years ago. When we look up at the stars, we're essentially looking back in time, and that's just our closest neighbor. The Milky Way, our home galaxy, is estimated to be about 100,000 light years across, and it's just one of billions of galaxies in the observable universe. Here's something even more mind-blowing. The universe is expanding. Not only is it incredibly vast, but it's also constantly growing bigger. Imagine baking a loaf of raisin bread. As the bread rises, the raisins embedded in the dough move farther apart from each other. That's kind of what's happening in the universe. The raisins in this case are galaxies, and the dough is the fabric of space-time itself. As space-time stretches, the galaxies are carried along for the ride, moving farther apart over time. This expansion was first observed in the 1920s by astronomer Edwin Hubble, and it has profound implications for our understanding of the universe. For one thing, it means that the universe had a beginning, a point in time, when everything was compressed into an incredibly dense and hot state. We call this event the Big Bang. The idea of parallel universes has captivated the imaginations of science fiction writers and armchair physicists for decades. But what does science have to say about the possibility of other realms existing alongside our own? The concept of parallel universes arises from various theories in physics, particularly in the realm of quantum mechanics. Quantum mechanics, the study of the very small, is notorious for its weirdness and counterintuitive predictions. One of these strange ideas is that particles don't exist in a definite state until they are observed. Instead, they exist in a superposition of states, meaning they could be in multiple places or states simultaneously. Some physicists have proposed that each time a quantum measurement is made, the universe splits into multiple universes, each representing a different outcome of the measurement. This is known as the many worlds interpretation of quantum mechanics. Section 5. Worlds beyond our own. The hunt for exoplanets. For centuries, humans have wondered if there are other planets out there, orbiting distant stars. Now, thanks to advances in technology, we know the answer is a resounding yes. In fact, we've discovered thousands of planets beyond our solar system, called exoplanets. and we're finding more all the time. The search for exoplanets is a challenging but incredibly rewarding endeavor. Astronomers use a variety of techniques to detect these distant worlds, most of which rely on indirect methods rather than directly observing the planets themselves. One common method is the transit method, which looks for tiny dips in a star's brightness when a planet passes in front of it from our perspective. Another method is the radial velocity method, which detects the wobble of a star caused by the gravitational pull of an orbiting planet. Section 6. Life as we know it, and as we don't. When searching for life beyond Earth, we often start with what we know. We look for planets located in the habitable zone around their stars, where temperatures are just right for liquid water to exist on the surface. Water, as we know it, is essential for life as we know it. But what if life elsewhere doesn't play by the same rules? What if there are life forms that thrive in environments we consider extreme or even hostile to life as we know it? Scientists are increasingly open to the possibility of extremophiles, organisms that can survive in conditions that would kill most Earth-based life. These hardy creatures have been found in scalding hot springs, under immense pressure in the deep ocean, and even in the frozen wastelands of Antarctica. Their existence expands our definition of what's considered habitable, and raises intriguing questions about the potential for life to exist in places we might never have imagined. Section 7. The Great Silence. Pondering the Fermi paradox. Given the vastness of the universe and the sheer number of stars and planets out there, it seems statistically improbable that we're alone. Yet we haven't found any concrete evidence of extraterrestrial civilizations. This discrepancy is known as the Fermi paradox, named after physicist Enrico Fermi, who famously posed the question, "Where is everybody?" The paradox highlights the apparent contradiction between the high probability of extraterrestrial life and the lack of contact with such civilizations. There are many proposed solutions to the Fermi paradox, ranging from the sobering to the downright bizarre. Some scientists speculate that intelligent civilizations may be inherently self-destructive, wiping themselves out through nuclear war or environmental devastation before they have a chance to reach out to the stars. Section 8. SETI. Listening for whispers in the cosmic ocean. Despite the challenges posed by the Fermi paradox, the search for extraterrestrial intelligence, or SETI, continues in earnest. Scientists involved in SETI are using a variety of methods to search for signs of advanced civilizations, hoping to catch a glimpse of a distant beacon or intercept a stray radio transmission. One of the most well-known SETI projects is the use of radio telescopes to scan the skies for artificial signals. Radio waves are a good choice for interstellar communication because they can travel long distances through space with relatively little interference. However, the vastness of space presents a significant challenge. Imagine trying to find a needle in a haystack the size of a planet. To increase their chances of success, SETI researchers are developing increasingly sophisticated signal processing techniques and targeting their searches on star systems that are considered potentially habitable. Section 9. An unending quest. The search for life beyond Earth is a journey into the unknown, driven by our innate curiosity and our desire to understand our place in the cosmos. While we have yet to find definitive proof of extraterrestrial life, the journey itself has been filled with incredible discoveries and has expanded our understanding of the universe in profound ways. The vastness of the universe, the possibility of parallel worlds, and the ongoing search for exoplanets all point to a cosmos teeming with possibilities. Whether or not we're alone in the universe remains one of the most profound and enduring questions of our time. But one thing is certain: the quest for answers will continue to inspire and challenge us for generations to come.